Our third panelist, Dr. Faith Fitzpatrick, is a research hydrologist at the United States Geological Survey, Wisconsin Water Science Center in Middleton, Wisconsin. She has spent much of her career studying how rivers respond to land use, disturbances, and floods. She served as the Scientific Support Coordinator for the United States Environmental Protection Agency's Federal On-Scene Investigator from 2011 to 2014 during emergency response cleanup operations for the 2010 Enbridge Line 6B pipeline rupture of diluted bitumen into the Kalamazoo River, Michigan. Her particular focus area was the fate and transport of submerged oil and oil sediment. Oh, you can do whatever you need to do to make me sorry. Yep. Go ahead.
Hi, thanks. What I'll cover just briefly today in this panel slideshow is a little bit on what caused the large spill and how it was cleaned up, and what determined some of the cleanup endpoints for it, and then a little bit on remediation too. So I just kind of cover things. There was a lot going on with that, so I'll just cover some of the highlights in this 10 minutes. Let's see. And then in summary, I just thought I'd start out with a couple bullets that summarize some of the major things that came out of the large spill. And this was one of the largest spills of diluted bitumen. As Elizabeth showed earlier, the bitumen is really sticky, and it gets stickier as it weathers, and it easily mixes and adheres with river sediment and sinks. Rivers in particular, this is kind of a new thing that was in a river system, in fresh water, transports submerged oil and oil sediment for many miles, especially during floods. It gets worse. Submerged oil and oil sediment, it can take a long time to clean up. Special containment is needed because of the flowing water conditions. And then the ice and cold weather kind of complicate recovery and containment. Here's what the location of the spill, a little bit about it, line 6B. The spill rupture point was in Marshall, Michigan. It was about halfway through the lower peninsula in the southern part. It was about 100 miles from Lake Michigan, luckily. The reported amount was 843,000 gallons released over 17 hours. The rupture happened in a wetland, which then oil went into a creek and then affected 38 miles of the Kalamazoo River. Early on, the voluntary evacuation zone, this is a slide showing that, and this is from a recently released report that just came out a couple weeks ago from the Federal On-Scene Coordinators. It's called the desk report for the Enbridge oil spill. So it's a summary of that, the spill based on the EPA's Federal On-Scene Coordinator. So you can see the release site here in the wetland, the creek, and then the Kalamazoo River up above. Here's a photo showing what the spill looked like as it was going over a dam at one of the impoundments. One of the other complicating factors is the wetland. There was quite a bit of wetland in the floodplain area of the Kalamazoo River, as shown here, and it happened during a flood with a 4% probability of happening. So that we can talk about that being a 25-year flood. So it was a pretty big flood that covered the floodplain areas. There was no fish kill associated with it, but it did impact several thousand turtles and also some birds. Here's a photo kind of showing that kind of molasses-looking substance. This is the weathered product. And then also a graph showing the API gravity and the viscosity of, and here's the Cold Lake blend. That was what was spilled in the Kalamazoo River. And an API gravity of 10 is about equal to the density of fresh water. So the Cold Lake blend is a heavy crude. It was lighter than water. It was about 0.93 with the diluent, which was a natural gas condensate, so that those pipelines kind of carry a lot of different materials, so that natural gas condensate helps to make the bitumen flow better in the pipes. Once it weathered, the density was down to about 0.993, so in this case, we never had anything that showed that it was denser than water. But it does have a very high affinity to stick to sediment and organic matter, which was present in the Kalamazoo River. Here's a timeline with just some highlights of the Kalamazoo River cleanup. Administrative order was issued by EPA the day after the spill. Early on, and this is really a great success story from the spill, a really large percentage of the oil was cleaned up using floating oil and conventional recovery methods. And so that happened within a few months. But you can see this long time scale going down to the fall of 2014 was spent in the submerged oil recovery. And so that was what accounted for most of that 1.2 billion costs associated with the cleanup. 2011 show a couple slides showing the agitation toolbox techniques that were used, and then 2012 and 13 enhanced deposition with a lot of sheen monitoring done and that environmental benefits analysis. And then EPA's work ended with targeted dredging in 2013 and 14, and then in November 2014 they transitioned the cleanup and the assessment and monitoring to Michigan DEQ. So here's a little bit of video showing the spill, and this is basically oil going over the Ceresco Dam. And you can see again, it gets a little thicker as it weathers and is exposed to air. This is an agitation toolbox method that was used, so it's basically like a rototiller of the sediment bottom that brings up a portion of the oil, which is then cleaned up off the surface of the water with absorbent boom. And you can see that with these many boats here with the absorbent boom floating behind them. Here's a yellow iron kind of mixing up the sediment there with the boats following. And an absorbent boom along the shoreline. Here's another photo of kind of what it would look. This is in 2012, so this is this persistent sheen problem that was happening in the river. And here's what the oil looked like. This is mainly mud, and you can see these really light gray areas or little bits of oil. This is kind of what it looked like and what was causing the sheen. So it wasn't like tar balls, it was like mixed, it was like sludge that you get like along riverbanks when you step in the mud. Here's what some of it looks like. Some of it is kind of like flakes. When we looked under a microscope with fluorescent lighting, you kind of see this then. This is kind of that mixture. We call these oil particle aggregates with mixtures of oil droplets and sediment shown in the brown. Here's just another video. As you disturb it, that would bring up some of the oil as sheen, as you can start to see in here. So by 2012 then, there was quite a bit of the river that still, these red and orange dots show areas of the river that had moderate to heavy oiling, like I had just shown in the video there. A lot of it was concentrated in 3 impounded sections, the Ceresco, Battle Creek, and the upper part of Morrill Lake. There's about 20 or about 200 and some targeted areas along the river that still needed to have oil addressed, and in order to do that, we used a net environmental benefit analysis to come up with that, because it was at the point where there was no human health issue anymore, and it was at the point where we needed to look at the balance between the ecological harm in removing the oil or leaving it in. So it became a balance of that. So we had a national and local team of experts look at these areas individually with the operations response staff to go through a set of recommendations to see whether they should have some kind of recovery done for them or if they should be left in place. And so this is like one of the few areas where there was some very special native vegetation where that would be more impacted by the actual dredging or removing of the sludge and having it stay in place. Other green areas had, over time, the oiling problems went away. And I'll kind of show some of those dots again, showing each one of these represents one of those points where there was what was called polling done to see how much oil was present. This is the areas that were dredged in 2013 and 14 then, the 3 impoundments, and then there were also some enhanced sediment traps, 4 of them located along the river in backwater areas. Here's some more video showing some of that dredging that happened. This is in Suresco impoundment. It was done with physical hydraulic dredging. There was also quite a bit of excavation, dewatering and excavation that was done too. And then this is a shot of showing an overview of the remediation that was set up along Morrow Lake in that delta, and some more shots of the removal. There was, as Elizabeth mentioned, things would slow down during the winter season because of the ice. And then another aspect that was done was a dam removal at the Suresco impoundment because it was easier and more effective to do excavation as opposed to dredging in that region. So that's what this is here. Some of the federal on-scene coordinators' recommendations that came out of that report that I had just mentioned earlier, I think these would maybe fitting for you all. The use of conventional techniques, to use those as effectively as possible before that weathering window closes and the oil sank. They had about 10 days, 10 days to 2 weeks when most of the oil sank because it was mixing with the sediment. Submerged oil containment systems needed to be in place robustly and early. Prepared to conduct aggressive air monitoring and sampling. This is especially important early on because of that diluent and the volatilization of the diluent. Practice strong area planning to optimize strong response organization early on. In this case, they didn't know what product they were dealing with, which added some level of need in the organization at the beginning with the emergency responders. And then there's quite a bit of science that happened with this cleanup, and that started in about 2011 with the submerged oil again because of the new aspects of that. So the recommendation was to have that happen early on.
Faith, your turn actually.
Yep. Okay, that's it. Thanks.